Assalamualaikum and very good day to all of you. Today, we are going to learn about a new topic that is descriptive statistic. First of all, what is statistic? Statistic is a set of mathematical procedures for describing, synthesizing, analyzing, and interpreting quantitative data. So, the selection of an appropriate statistical techniques is determined by the research design, hypothesis, and the data collected. So next, what is descriptive statistic? Descriptive statistics are used to describe the basic feature of the data in a study. With descriptive statistic, you are simply describing what is or what the data shows. They provide simple summaries about the sample and the measures. Together with the simple graphics analysis, they form the basic of virtually every quantitative analysis of data. We use descriptive statistics simply to describe what's going on in our data. It is also permit the researcher to describe many pieces of data with a few indices. Now, let's look at types of descriptive statistic. The first one is distribution. The graphs always used to represent the data and enable the researcher to see what the distribution of scores looks like. The second one is measures of central tendency. It is enabling the researcher to determine the typical or average score of a group of scores. And the last one is measures of variability, which is enabling the researcher to indicate how spread out a group of scores are. The distribution is a summary of the frequency of individual value or range of values for a variable. The simplest distribution would list every value of a variable and the number of persons who had each value. For instance, a typical way to describe the distribution of college students is by year in working experience, listing the number of percent of workers at each of the certain years. Or, we describe gender by listing the number of percent of male and females. In these cases, the variable has few enough value that we can list each one and summarize how many sample cases had the value. But, what do we do for a variable like income or GPA? With this variable, there can be a large number of possible values, with relatively few people having each one. In this case, we group the raw scores into categories according to range of values. For instance, we might look at GPA according to the letter grade range. Or, we might group income into 4 or 5 ranges of income values. Now, let we move to the second type of statistic descriptive, that is central tendency. The central tendency of a distribution is an estimate of the center of a distribution of values. There are 3 major types of estimates of central tendency. There are mean, median, and mode. The first one is mean. The arithmetic mean is defined as the sum of the score divided by the numbers of score. The mean is represented by the symbol X bar. Now, let us see the formula for mean. Mean is equal to the sum of individual score divided by the number of scores. Examples. Let's say there were 4 students taking a test. The scores were 90, 70, 67, and 50. The mean of the sample is the sum of individual scores divided by the number of scores. So, 90 plus 70 plus 67 plus 50 divided by 4. So, the mean is 69.25. Now, we will discuss about properties of the mean. The mean is sensitive to the exact value of all the scores in the distribution. A change in any of the scores will cause a change in the mean. The mean is very sensitive to extreme score. If we added an extreme score, one far from the mean, it would greatly disrupt the balance. the mean would have to shift a considerable distance to re-establish balance. Now, let we look at median. Median is the score that found at the exact middle in the set of values. One way to compute the median is to list all scores in numerical order and then locate the score in the center of the sample. For example, if there are 100 scores in the list, the score number 50 will be the median. The last type of central tendency is mode. The mode is the most frequently occurring value in the set of scores. To determine the mode, you might again order the scores and then count each one. The most frequently occurring value is the mode. Look at the set of number. In our example, the value 15 occurs 3 times and is the mode. In some distribution, there is more than one model value. For instance, in a bimodal distribution, there are 2 values that occur more frequently. The last type of descriptive statistic is dispersion. Dispersion refers to the spread of the values around the central tendency. There are 2 common measures of dispersions, the range and the standard deviation. The range is simply the highest value minus the lowest value. In our example distribution, the highest value is 36 and the lowest is 15. So, the range is 36 minus 15, that is 21. The range is easy to calculate, but gives us only a relatively crude measure of dispersion. Because the range really only measures the spread of the extreme scores and not the spread of any scores in between. Therefore, it has a little statistical value as compared to the standard deviation. Standard deviation is more accurate and detailed estimate of dispersion because an outlier can greatly exaggerate the range. The deviation score tells how far away the raw score from the mean of its distribution. Look at the sample below. First, you find the mean value by adding all scores and divide by the number of scores. For examples, 2 plus 5 plus 4 plus 1 plus 6 plus 3 plus 7 plus 5 plus 4 and plus 7. Then you will get 44. Then divide by 10. You will get the mean is 4.4. Then find the deviation by subtract the raw score with the mean. For examples here, the raw score 2, you minus with 4.4, which is 4.4 is the mean. So the answer is negative 2.4. Do for all the raw score and minus with the mean. And finally, you have to find the sum of squares value for the deviation. From the calculation before, we put the value into the formula. The formula for standard deviation is the square root of the sum of the squared deviation from the mean divided by the number of scores minus 1. Look back at our data. The sum of the squared deviation from the mean is 36.4. Then, divide the value of 36.4 by the number of scores minus 1, that is 10 minus 1, that is 9. So, 36.4 minus 9 is 27.4 and the square root of 27.4 is 2.01. Here you are. Now, you get the standard deviation value for the data. So, that is all about our lesson today. You have learned about the descriptive statistic. I hope now you will know how to analyze your data descriptively and choose the right types of descriptive statistic to report your data. Thanks all for now. Thank you.